So we are up to definition of summation notation. I'm going to write it just because I don't think it turned out as well as I had hoped. Okay, if I have the sum I runs from 1 to n of a sub I, this is just a fancy way to say I am adding up all the terms in a sequence. So this means a sub 1 plus a sub 2 plus a sub 3 and so on until I get up to a sub n. I is called the index of summation, n is the upper limit, and 1 is called the lower limit. So this is actually very, very simple. In example 8, it says find each sum. So I have the sum I runs from 1 to 5 of 3i. This means 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. Okay, see how easy that is? So that's 3 plus 6 plus 9 plus 12 plus 15. And I want to talk to you a moment about how you can add numbers. Like suppose you were asked to do this without a calculator. And you shouldn't think, oh my gosh, that's impossible, that's so hard. If you think about it, what's 6 plus 9? 15. What's 3 plus 12? Plus 15. I have 3 sets of 15. So you don't have to start with 3 plus 6 and then go 18, even though that's not horrible. But sometimes it's easier to figure out how to group numbers together. All right, now in letter B, and I want to point out because now it changed to a letter K. I, J, and K are very common letters they use as indices of summation. If you think back to your math experience up to this point, functions, they use F, G, and H. When they're talking about variables, they're using X, Y, Z. When they talk constants, they do A, B, C. And if they're doing polynomials, they do P of X, Q of X, and R of X. So it's just kind of tradition. It doesn't have to be. But something else I want to point out to you is your lower limit of summation doesn't have to be a 1. So in this case, I have the summation, k runs from 3 to 6 of 1 plus k squared. So that means I have 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1 plus 6 squared. Excuse me, thank you. What I want to point out to you, maybe, is that there are not 3 terms. We normally think 3 to 6, that is a difference of 3, which it is, but you're counting 3, 4, 5, 6. That's actually 4 terms. All right, now let's also talk about addition. I have 4 ones. Well, 4 ones is 4. And then I've got 9 plus 16 plus 25 plus 36. Now let's talk about grouping these. 9 plus 16 is 25. 25 and 25 is 50, and what's 4 plus 36? 40. Do you see how easy that is to add it? Yeah.
I thought of like when you always have like 3 squared plus 4 squared, like you think of like a 3, 4, 5 triangle, so you know it's 5 squared, so it's 25.
True. Yeah, that's cool. Yeah, if you think about 3 squared plus 4 squared when you're doing Pythagorean theorem, that is 5 squared. Yeah, that's true. All right, now let's try letter C. This is 1. Now notice the lower limit of summation is a 0. So it's 1 over 0 factorial, 1 over 1 factorial, plus 1 over 2 factorial, plus 1 over 3 factorial. And remember, a summation is you are adding the terms in a sequence. Now, I don't want to do this one by hand, and I don't think you want to do it by hand. So take out your calculators. And do you remember where the factorial button is?
No.
It's under Math, Probability. All right, so here we go. You're going to do 1 divided by, and if you press Math and go over to Probability, Math, probability, there's the factorial button, okay? Oops, I forgot my 0, didn't I? So, and then I can do plus 1 divided by, well, I know 1 factorial, right? Plus 1 divided by 2 factorial, I know 3 factorial. What number is that? You know what number that is? E. So, this is approximating E. If I go to infinity, it does in fact equal E. But we're getting about 2.718, okay, which is it's approximating E. If you're going to go into engineering and you'll take Calc 2, you'll see this. You'll see series in Calc 2. All right, properties of sums. Go ahead and take a moment and notice my I equals 1. It's supposed to be underneath here, but when I was trying to insert these, they didn't work as well as I'd hoped. So this is the summation. I runs from 1 to n of a constant times a sub I. What that means is if I look at letter A above, my summation, I runs from 1 to 5 of 3i. I can rewrite this as 3 times the sum. The summation I runs from 1 to 5 of I. And if you look back here at this work, couldn't I have factored out all the 3's and then did 1 plus 2 plus 3 plus 4 plus 5? That would have worked. If I have a summation of a sub I plus b sub I, you can actually find the sum of a sub I and add it to the sum of b sub I. And then the same is true with subtraction. If I have the sum of a difference, I can break it apart into the sum of a sub I minus the sum of b sub I. Okay, so these are properties that we will eventually use to help us find sums. Then the next thing is I'm going to show you how to do this on your calculators. If you have the newer calculator, the TI-84s, your life's going to be very, very easy. And if you have the TI-83, I'm going to have to show you, it's a harder way to go. But the steps in here actually follow, because these notes are several years old that I've used. Does everybody have it now? Got it now?
You're recording.
I am recording, yes. Okay, so on the older calculator, you're going to do these keystrokes. Second stat, math, number 5 is sum. Then you do second stat, ops, 5 is sequence. And you're going to see this. And so we're first going to do example 8a. And so you're going to put 3x. If you have the newer one, don't do this, okay? This is for TI-83 people. You do 3x, comma, we're doing it in terms of x. The summation went from 1 to 5, and we're going to go by ones and press enter. Now, if you have the newer calculator, I'm going to rock your world.
F2.
Let's do math 0. If you do math 0, do you get this?
It's also
I do.
alpha F2.
Hey,
and that's the
there we
second
go.
one.
Alpha F2, okay.
Oh.
So now, let's use the letter x, okay? So we're going to go x is 1 to 5, and it was 3x. and you press enter, and it does them automatically. So we.
Can you do it on my homework?
Okay, on the worksheet tonight, you can do half of them on the calculator and half of them have to be done by hand. Because I want to make sure you know how to navigate it by hand. Let's try one more. Do you see towards the bottom of the page it says, let's try another one using the calculator. It says, you want to find the sum, I runs from 0 to 5 of 2i squared. Let me do it the other way for my TI-83 users, okay? Let me go through the keystrokes. You're going to do second stat, you arrow to math, number 5 says sum. I do second stat, arrow to ops, number 5. So mine might look a little different. I'm going to put 2x squared, the variable's x. This time we're starting at 0 to 5 and you're going by 1. So do you see on the front board, I've already written it out. And if I press enter, yours should look like this, okay? TI-83 people, do you have this? Yes? 2x squared, comma x, 0 to 5, and you're going by ones, and you should get 110. Did you all get 110s? Oops. All right, a series. A series is a sum of the terms in a sequence. Again, a sequence is a list of numbers that have some sort of pattern to them, and a series is when you add the terms up. So in example 9, it says for the series summation, I runs from 1 to infinity. And you might think, I can't do it to infinity. And you're going to be surprised, you can. This is 3 over 10 to the I power. So it first says in letter A, find the third partial sum. So I need to tell you that a partial sum means you're starting with the bottom index and going that many terms. So if I want the third partial sum, that means I'm doing 3 over 10 to the first plus 3 over 10 to the second, but I know that's 100, and I have 3 over 10 to the third. That's called the third partial sum. Well, that's 0.3 plus 0.03 plus 0.003. That's 0.333. Now it's saying we want to find the sum if we add these up infinitely many times. Well, what would it be? 0.3 repeating, which is 1/3, right? So you can find an infinite